So let's start the class. So good evening guys. So we are seeing the Newton's laws of motion right now. So in last class what we have seen, the problems in the laws of motion, like free body diagram we have drawn, and then we have seen the how the acceleration will takes place in the each blocks right now. So now we will see some more questions in that types. Okay, so this was the last question we have seen, no, when two blocks are there and one more block like M3, M2, M1 was there. So I need to find what is the acceleration of this block. Now this next question is, two masses M1 is equals to 5 kg and M2 is equals to 4.8 kg tied to a string are hanging over a light frictionless pulley. What is the acceleration of the masses when system is free to move? When system is free to move, in the sense, I need to denote the masses here first. So if M1 is equals to 5, in the sense, what will happen here? This is 5 kg and this one will be 4.8 kg. In which side object will move? Obviously the object will move towards down of the M1. For M2 it will go upside, right? Now the free body diagram will be looking like, so this is my mass 1, so weight will be towards down, right? So what will be the weight? M1g, and the tension will be towards up. Is this different rope or same rope? It's a same rope, so the tension will be T, right now. So in which side it is going down? In which side it's going down, no? So towards down the acceleration for the first block. What about the second block, M2? M2 will be having tension towards up and M2g will be towards down, and acceleration is towards up for the M2. Now if I write the equation for this, how will be the equation? M1g minus T will be equals to M1a, right now. And for the second one, what will be the equation? T minus M2g is equals to M2a. Equation number 1, equation number 2. If I add both the equation, now what will happen? T and T will get cancelled off. M1g minus M2g is equals to M1a plus M2a. Right now, I will substitute the values of M1, M2g. So what is M1 here? 5 kg minus 4.8 kg, and I have taken g commonly outside, which is 9.8 they have given. They have mentioned 9.8. If they are not mentioning, no, we can take 10 approximately to calculate easily. For the calculation purpose, we will take the 10. Okay. Now will be equals to 5 plus 4.8 of A, right now. So what is 5 minus 4.8? It is 0.2. So 0.2 into 9.8, 5 plus 4.8 is 9.8. So when I take to the other side, it will become divide by 9.8 will be equals to acceleration. So 9.8 and 9.8 will get cancelled off. So acceleration will be 0.2 meter per second square. So option 1 will be the answer. Okay, take down. It's fine. Due to reflection it will be. When we are saying in this direction, it will be fine. You can take it fast. We'll go for the next question. We'll see PYQs of this models also, okay? How the question will be asked in NEET point of view, like how the PYQs has been there. So keep in mind, when they mention G as 9.8, take it 9.8 only, okay? Don't take it 10, okay? So for the if I do here, no, 9.8 and this one if I take it, I mean 10 and this has 9.8, so the calculation will be different, like it will be get clumsy there. So if I take 9.8 what they have mentioned, if I take this one as 5 plus 4.8 again 9.8, so it will get cancelled off easily. Okay. Done. Okay. So the next question will be, so inclined plane. Okay. So before going into inclined plane now, I'll give the method how to take the components for the inclined plane. Okay. So listen carefully. When I consider an inclined plane now, this is my inclined plane. So object is lying over here, having mass m. So this is my angle theta, right now. So when object is in the surface like this, in the horizontal surface, and the mass having, I mean object having mass m, so what I can do is, normal I can write directly, and this one will be my mg. So normal will be equals to mg, right now, in the normal cases, like in the horizontal cases. When I take in a plane, so normal will not be equals to mg, because when I draw the diagram here, no, so normal will be like this and mg will be towards down, no, yes or no. So both are not in the same axis, so it will not be equals to, I mean n will not be equals to mg. Okay. So what I should do here, okay, so what I should do in this case, I should take the components first, right now. So for taking the components, easy method is take 8 divisions, like axis you draw, x axis and y axis, and again split it, again you split it like this. Okay, now you split it. Now you take exact inclined plane here. Okay, exact inclined plane here. So where I can fit the inclined plane? I can fit here, no, theta. Okay. Now what I'll do is here, one theta is there. Leave one space. Alternatively write the thetas. So I have left one theta, left one again theta, again theta. That's it. No. Now what I'll do, whatever the force I have taken here, normal force and mg. So I need to take only for the any one of the components. I will take for mg now. Okay, mg is towards down, right? So can I write like this? This is my mg. Correct only, no? This is my mg. So angle which is closer will be my cos theta, away from will be my sin theta. So in this, which one is closer, right side or left side? Right side is closer. So which is this one will be my mg cos theta. So this one will be my mg sin theta. So can I write over here? Now I will extend this one. So this is my mg cos theta, and if I extend this one, this is my mg sin theta. Any doubt over here now to find the components of the mg, right now? So if angle is like this, we have got it. Suppose they have given like this. This is my theta and this is my object. Right now, this is my object. Now, my weight will be towards down, that is mg, right now, and the normal force will be here. Right. So same method. Take a 8 divisions. So 8 divisions are there, no? 1, 2, 3, 4, 5, 6, 7, 8. 8 divisions, no? Now take this angle now. This inclined plane I can fit over here, no? So I'll take this theta. Now what is mg? Towards down. So write that mg over here. So this is my mg, right now. Now if this is theta, I should take alternatively, no? So if this is theta means I should give one space, again theta over here, theta, theta. Right, no? Yes or no? Any doubt over here? Now which one will be my cos theta and which one will be my sin theta? Left side will be my cos theta because angle is closer. Here angle is away. So this is my mg cos theta, and this is my mg sin theta. So can I write now like this? So if I extend this one, this is my mg sin theta, and if I extend this one will be my mg cos theta. Right now. So now from these two cases now what we can understand is mg sin theta is helping me to go down. Right now mg sin theta, like this force is helping me to go down, no, which means object is going towards down only, no. If I keep the object in an inclined plane, what will happen? It will try to go down. Yes or no? It won't go up, no. It's practically impossible, no. Like if I take an inclined plane, if I keep an object, it will go down obviously. So which means this force is applying, I mean this, because of this force only it's going down. Can I write like this? Mg sin theta is equals to whatever the mass is there, I'll write that mass, and acceleration. So m and m will get cancelled, so acceleration will be g sin theta. So acceleration of this block will be g sin theta. Okay, if I keep simply, for example, if I take an object, if I leave like this, what will happen? Due to gravity it will go down. So which means gravity acts as a acceleration, no. Here also gravity acts as an acceleration, but due to this angle we should mention that angle, no, whether it is a sin theta or cos theta, right now. So mg sin theta force is helping me to go down, and g sin theta is the acceleration used over there. Okay, take this. So don't ever forget this method to take the components for this inclined planes. It will be easy to identify it. So what we can understand here, so for if I tilt like this also, the same mg sin theta is using to go down, right now. So the point is n is not equals to mg, n is equals to mg cos theta. Normal will be equals to mg cos theta, no. This is the axis now I am taking. So n will be equals to mg cos theta. Done. Can we move? Take this diagram also. So here also the acceleration will be towards down like this. So what happens here is mg sin theta is equals to mass into acceleration, mass and mass will get cancelled off, a will be equals to g sin theta. That's it. So similarly here also normal, that is n will be equals to mg cos theta. Okay, now we will go for that question. Okay, so in this question what they have mentioned is two blocks are kept on a smooth fixed slope as shown. These are smooth slopes. Okay, one is 2 kg block, this is 2 kg block, goes down with an acceleration, so it is going down, which means this block is going up, no? Yes or no? If this is going down, this one will be going up. So going down with an acceleration 2 meter per second, what will be the value of mass m? Okay, this is the thing they are asking. Okay, so now what I can do is I'll take the free body diagram for both the conditions. So this is one condition and this is one condition, no? So what happens is if I take the condition like this is the block, no? Yes, no? So it is attached with a rope. Yes, no? Rope in the sense, this one will be my tension. Yes, no? That's my tension. So we have drawn the free body diagram for this. So what will be the free body diagram? This is theta. So this is my mg. So this is my mg cos theta, and this one will be my mg sin theta. Fine, that's it. So this one will be my normal, right now, and object is going downwards, acceleration A. So what will be the equation now? Force in the direction of acceleration positive, opposite direction negative. So what I can do? mg sin theta minus t. T only, no tension, no. Should be equals to mass into acceleration. What is the mass? Let me take this as m1. M1 is 2 kg. Okay, this is m1. This is m. Okay. Now I will take the diagram for this condition. So this is the diagram for the second block in an inclined plane. So mg will be towards down. So this is m1 and this is also m1. So mg. So this is my mg cos theta, and this is my mg sin theta, and this is my tension T. So this is my normal n2. I will take this n1. Fine, no? So in this block, for this block, which is the direction of acceleration? Towards up. So can I write like this? No, this is the direction of acceleration. So which means the equation will be T minus mg sin theta is equals to ma. So here this angle they have given us 90, this one they have given us 37. What about this one? Sum of angle of triangle is 180. So one is 90, one is 37, remaining will be 53. So this one will be 53, no? Okay. Now they are asking for sin 53, sin 37 and sin 53, right? No? So to find sin 37, sin 53, what is the method we have came across? That is 3, 4, 5 triangle I have said, no? So to find that, what I told, this one is 37 degree. Yeah. One is 37 and one more will be 53, no? So this is right angle triangle, 90. So one is 53 I will take, one is 37 I will take. So which is larger number? 5. So keep 5 here, 3 here, and remaining is 4. That's it. 3, 4, 5 triangle. So when in this they are asking sin 37. Sin 37 means opposite by hypotenuse. So mass is 2 kg and this is 10 gravity. 3 by 5, no? Sin 37. So 3 by 5 minus t is equals to, mass is 2 and acceleration I don't know, a. Oh, they have given acceleration, it is 2. Okay. So it is 4 total, right? No? Similarly for this also, t I don't know, tension, t minus mass also I don't know, m into 10. What is sin 53? Opposite by hypotenuse, no? 4 by 5. So 4 by 5 is equals to 2a, no? So 2m. Acceleration they have given 2 and m. That's it, no? So can I add the two equations? What happens when I add the two equations? So this is equation number 1 and this is equation number 2. So 20 into 3 by 5, let me write like this. This is 1 times, 1 times and this is 2 times. So 2 2s are 4, 4 3s are 12. So 12 minus t is equals to 4 and this one 1 and this is 2. So t minus 8m, 8m no, is equals to 2m. Excuse me. When I add both of them, no, what happens? So t and t will get cancelled off. 12 minus 8m is equals to 4 plus 2m. Done. So take m one side and remaining term other side. What happens here? So 12 minus 4 is equals to 8m plus 2m. So which is nothing but 8 is equals to 10m. M will be equals to 8 by 10, which is nothing but 0.8 kg. This is the answer for this question, guys. That's it. So only thing what I should do here, I should take the components for the inclined plane and in which direction acceleration is going, that one will be my positive force, opposite will be my negative force, and equals to mass into acceleration. So equation I need to get it. From that equation, substitute the values whatever the things they have given and find the unknown. So by finding, we got the mass of the second block. Okay, take it down first. Done. Can we go for the next question? The remaining part is down. You can take this also. Okay. So the next question is completed now? Okay, fine. So two bodies of mass 4 kg and 6 kg are tied to the end of the massless string. The string passes over a pulley with a frictionless. The acceleration of the system in terms of g they are asking. Okay, acceleration due to gravity. So when I see over here, what happens is one is 4 kg and one more is 6 kg. In which direction object will go? The heavier side. So which is heavier side? 6 kg. So this one will go down and this one will go up. Right? No. So let me take the 6 kg block first. 6 kg block. Object is having a weight 6g. Right now mg, no, 6g, and the tension will be there. So both are having same rope, no, so same tension, no, so T I have taken down. So object is going towards down for 6 kg block, acceleration A. So for the 4 kg block, tension is towards up and 4g will be towards down and acceleration is towards up. Right now, now the equation will be, so 6g minus t will be equals to 6a and t minus 4g equals to 4a. That's it, no? 6g minus t. For this 4g, t minus 4g. So when I add the two equations, t and t will get cancelled. 4g minus, 6g, no? 6g minus 4g equals to 10a. That's it. So what happens here? 2g by 10 is equals to a, 1s and 5s. So g by 5 is acceleration. So what is the answer? Option 2. So this is NEET 2020 question. Okay, we'll see the next question. So this is NEET 2024 question. So horizontal force 10 Newton is applied to a block A as shown in the given figure. The mass of block A is 2 kg and block B is 3 kg respectively. The block slides over a frictionless surface. The force exerted by a block A on B. So which means I need to find what is the normal force in between them, no? So what I can do here, first I need to draw the free body diagram and for A and B, no, and I need to write the equation of both the blocks and get the answer for that. So can I give the answer for this question first? So acceleration is not given, I need to find the acceleration also, yes, no. So to find the acceleration, what is the easy method we saw? Acceleration is nothing but force by total mass of the system, right now. So force is 10, total mass of the system is 2 plus 3 is 5. So acceleration will be 2 meter per second square, right now. And the normal reaction. So for this block A normal reaction will be in this direction, for block B in this direction. Yes, no? So N will be equals to mass into acceleration. So mass is 3 kg, acceleration is 2. So answer will be 6, no? Can we do it? See, when we talk about a block A, force is acting, external force, that is F. So due to block B, a normal force is there, which will be in this direction, that is N. So object is moving in this direction, A, no? Acceleration. So for block B, due to block A, normal will be in this direction, that is N, and acceleration is in this direction. Yes, no? There is no other forces, no. This y-axis will be in equilibrium condition. It won't move. Only in x direction it is going, no. So what happens here? F minus N is equals to mass into acceleration m1 or ma. So N is equals to mass of B into acceleration. When I add both of them, N will get cancelled off. So F will be equals to mass of A is 2, mass of B is 3. So 2 plus 3 of A. What is force is 10. So 10 by 5 will be equals to acceleration. So this is once and this is twice. So acceleration will be 2 meter per second square. So when I talk about the second or first equation, if I substitute the value, no, I can get the value of N. That is a force exerted between A and B. So I can use the second equation. No, second equation gives N is equals to mass of B is 3 kg and acceleration is 2 meter per second square. So total will be 6 Newton. So option 4 is the answer. Done? See, that's what here. So Newton's law for a system. So if external force is acting, the sum of mass into acceleration will be taken place there. It's like m1a1 plus m2a2 plus m3a3 up to mn an. Okay. So F external will be like net external force is this one. Okay, net external force. So masses of the each system, acceleration of the each system. So suppose if I consider 3 blocks having a mass m1, m2, m3. Suppose external force is acting over here. So each block experience its own acceleration a1, a2, a3, which means F external will be equals to m1 a1 plus m2 a2 plus m3 a3. If any other blocks are adding over there, again I'll add the equations. Okay, this is the thing we have seen now in the last slide. Take it. Done? Can we go for the next one? Okay. So next is spring force. Okay. A spring force is the restoring force produced by a spring when it is stretched or compressed. So when I talk about a spring, no, spring will be there. If I stretch this spring, what happen? It will restore its original position. Or any rubber we can take. Okay. Okay. If I stretch, what will happen? It will restore its original position. If I compress, what will happen? Again it will restore its original position. No. So stretching or compressing, which is nothing but stretched or compressed, in terms of x will denote. Okay. So a spring is always try to return to its natural length. Okay. So the stretched length is x, or compressed length is also x. So like according to Hooke's law, no. So the relation between force and displacement of a spring is given by. Thing is, if I apply more force, what will happen? More displacement happens. No. So can I say like this? F is directly proportional to x. Yes, no? F is directly proportional to x. So if I apply more force, more displacement happens. If I apply less force, less displacement happens. So according to this, no, we got the formula F is equals to minus kx, where F is, like, let me take this as Fs. Okay. So spring force and k is the spring constant. So to remove the proportionality, we are adding a constant called k, spring constant, and x is the displacement from the natural length. So here negative sign means that the force is always opposite to the displacement. If I apply a force in this direction, displacement will be opposite. So restoring nature. Okay. Take it. Muralidhar, hello. Done? Okay. So the next one is, so keep in box this formula. Okay. Spring force is nothing but minus kx. So x is nothing but it's a stretched length or compressed length. Okay. So next one is equivalent spring constant. So we are talking about two types. So one is parallel connection and one is series connection. So when they are in parallel connection, no, if I apply a force to stretch, so everything will be equally stretched. When I apply in a series condition, it will change over there. Yes, no? So when a spring are connected in a parallel, then we can replace them by a single spring constant. So which is nothing but K1 and K2 are the spring constant for the spring 1 and spring 2. So total spring constant will be K1 plus K2 for the parallel condition. Okay. So it is for the two springs. For n number of spring, K1 plus K2 plus K3 up to Kn. So when they are in series condition, how can I write? So 1 by K1 plus 1 by K2 plus 1 by K3 up to 1 by Kn. Okay. So two formulas are there. One is for the series and one is for the parallel. So for parallel, K parallel will be equals to K1 plus K2 for the two springs. When I talk about the two springs for the series, 1 by K will be equals to 1 by K1 plus 1 by K2. Right now? So is there any doubt in this now? Spring. So we will see the problems related to spring in the upcoming classes. Okay. We will meet in the next class, guys. Bye.